let's define the heat duty. I actually already defined the heat duty, but we will put it in an official context. So we define this thermodynamic balance as the heat duty of the heat exchanger. So we can write this, again, as the hot side or the cold side, but these are ultimately equal, and that's what we refer to as the heat duty. This is our design equation. So we have our design equation. So thinking about this free body diagram or this energy diagram we drew, we have the heat duty is MCP, and then let's just say delta T. So if this is hot, it would be the mass flow rate of the hot side, specific heat of the hot fluid, and the temperature difference, again, as the hot fluid starts at some hot temperature and then cools down to get to some low temperature. So this delta T is of the hot fluid. That's our heat duty. Our design equation is that Q equals U AS delta T log mean. And now that's what we need to get a handle of, is what are these log mean equations? And I have them written down here. So if we have a counter flow, log mean temperature difference for counter flow. All right. We define this as THI minus TCO. So the inlet hot temperature minus the outlet cold temperature minus THO minus TCI, outlet hot temperature, minus the inlet cold temperature, over the natural log of temperature difference between the hot inlet and the cold outlet, and the hot outlet minus the cold inlet. All right, and then for the parallel flow heat exchanger, the log mean temperature difference, log mean temperature difference is THI minus TCI minus THO minus TCO. Looking at the deltas basically at the inlet and outlet of the heat exchanger overall, natural log, the hot inlet temperature minus the cold inlet temperature over the hot outlet temperature over the cold outlet temperature. All right, so you have the log mean temperature difference for the counter flow heat exchanger and the parallel flow heat exchanger. And let's do a real quick analysis. What happens when the hot temperature is the same? It doesn't change from hot in to hot out, as in the case where we had steam coming into that shell side. So in that case, actually maybe we just look at these equations. THI minus TCO minus THO minus TCI. So we could rewrite this as TH, actually let's just do this. So if we have steam, on the hot shell side of this exchanger, then log mean temperature difference is T steam minus TCO minus T steam minus TCI, all over the natural log T steam minus TCO over T steam minus TCI.